Here we go. So we're going to talk about energy flow. And again, let's look right here. The energy of the Earth. Earth's energy comes from two different places. What's this two place right here?
The sun.
Tell me, Jonathan, for the first one. Tell me here, Laura Lynn, from the second one.
The inside of the
Inside the Earth, right? There's energy inside the Earth. Good, you got it. Okay, so as we've talked about how energy from the sun, and we call that solar energy, right? Impacts Earth, and we're gonna look at these pictures right here. And so, how do you think? 3 ways Earth's organisms use energy from the sun. So, what do they do right here? What do these plants do?
Grow.
Okay, what do they do though? They use the sun to what?
Provide food.
Provide food. What do you say? What do they use the sun for? Tell me, Tyler.
energy.
Huh?
Energy.
Well, they're giving energy to the bee, right? And the bee goes and it takes the energy, takes the nectar from the flower and it makes honey out of it, right?
Yeah.
How about this right here? What does this do? This actually lets us know how much energy the sun's giving us, right? Gives the what the temperature is. What about this right here? What are these?
There are solar. Where did my thought work?
Solar panels, right? And they actually they take energy from the sun and they help convert it to electricity. That's free energy, by the way. After you, of course, you have to buy your solar panels, and quite frankly, let me tell you, solar panels are a little bit too expensive for the average person to buy right now. But maybe by the time you're adults, maybe everything will be solar. Okay, hopefully, maybe it won't be so expensive. Okay. Okay. If not you, at least your children. I suspect that at least your children will have solar energy in their houses. It'll be cheap. Okay. Hopefully it will be. Okay, so let's look right here. So let's look at Earth's internal energy, because we said there is energy from the sun, and then there's also internal energy from the Earth. So the energy needed to cause the changes seen in our last section comes from beneath the surface of the Earth. Did you know that our heater and cooler, the cooling system right over here that's inside this thing, is controlled? It is using thermal energy. Right out here in the football field, there are pipes down 50 feet in the ground. Water goes through those pipes, and depending on whether I tell it to be 70 degrees in here or 80 degrees, the water is going to either come up cold or hot through a little, kind of like a radiator in your car. Water circulates through your engine. Similar process here, and it gets cool or hot in here. And it's hot water or cold water, depending on what I tell it the temperature to be, coming from the surface, underneath the Earth, 50 feet down. Okay, so the heat of the inner core, this is the very center of the Earth, right? The inner core right here. The heat of the inner core, outer core, and mantle, here's the outer core, here's the mantle, is linked to many large-scale Earth processes such as plate tectonics, geysers. What's a geyser? Hello, Leah. What's a geyser? Tell me what a geyser is, Edward.
A geyser is like, I guess you could say it's a water volcano.
It's a water volcano. You're exactly right. It's water that shoots from underneath the Earth, right? Every so often. Okay, so geysers and volcanic eruptions, okay? So look right here. You notice, did I tell you guys the other day, how many layers of the Earth did we say there were? 4, right? Well, look right here. What are they saying here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So different scientists, and they're all correct. And I was taught when I was young there was just a crust, mantle, and core, right? I was taught there was only 3. You're being taught there's 4. Some scientists break these down, and they're all correct. Even I'm correct to say there's a crust, a mantle, and a core. But you can break those down into inner core, outer core, mantle, upper mantle, crust, and so on, right? And then you can go on up right here, troposphere, stratosphere, mesosphere, thermosphere. Oh, when you get up to the thermosphere there now, that's where you get, if you try to go through that, you get fire. Okay, so let's move on here. Okay, so convection in the Earth's mantle. What's convection? Let's figure out what convection is. So the materials in Earth's mantle are constantly in motion. Are you listening? anything that's that has a lot of energy, a lot of heat, is going to be in motion, right? Think about an ice cube. Is it moving around? No, it's just there, right? And it starts to melt. How about boiling water? Does it move around?
Mm-hmm.
Oh, yes, it does. It rolls. It's what's called. You get water to a point where it's called rolling boil, and that's actually it's convection. The cool water is going to the bottom. It heats up, goes back up to the top. As it goes back up to the top, it cools down, and it's a cycle, right? Okay, so as you travel through the mantle, the temperature changes, and to distribute this heat evenly, there are convection currents, and convection currents are simply hot air. Let me answer the phone here. This is Hughes. I will. Okay, thank you. Aaliyah, they want you back to Miss Owen's room. And you need help getting in the chair? I'll help you. Oh, you got that going on. Okay. Does it need to be all the way closed?
It doesn't have to be.
Well, let's see if I can get all the way.
I heard you say,
Almost like stuck there.
I heard you say.
Okay. Take this, you have a seatbelt on here, don't you? Open the door, for Aaliyah. John, open the door for Aaliyah. See you later, Aaliyah. Okay, so,
Will you put
here we go. Okay, so that happens sometimes, right?
Yeah.
Lessons get disturbed, that's okay. Okay, it's not the end of the world. Okay, so let's go back up here to what we're talking about here. Again, I need your attention here. The materials in Earth's mantle are constantly in motion, as we said. And as you travel through the mantle, the temperature changes. Do you think it's going to get cooler as we get deeper in the Earth, or hotter?
It's gonna get hotter.
It's going to get hotter, right? Okay, so to distribute this heat evenly, there are convection currents that move between the warmer and cooler sections. And the cooler section is going to be up here, right? The warmer is going to be down toward the inner core. So these currents are able to travel through the semi-solid rock in the mantle, and here's the mantle, right? Causing changes to the land above. Okay, so you may have heard of the term convection, right? Anybody not ever heard the term convection? Has anybody not ever heard the term convection?
I think I have
Mm-hmm.
from my brother. Or another from
Where you at here?
he talking about something.
Mm-hmm.
I don't listen to my brother.
Yeah, let's not go anyplace else, get it? Okay. Lexi, turn around. Okay, so you may have heard the term convection. Anybody not heard the term convection? Okay. So convection refers to the warming of a substance caused by the circulation of different temperatures of air. Okay, different temperatures of air. Cool air, hot air, right? That's all got to do with convection, yes.
Like a heat wave, basically.
Like a what now?
Like a heat wave or Antarctica in one?
Like a heat wave or Antarctica, right? You're exactly right. Okay, so in a convection oven, a fan helps circulate the warm and cool air so that the food inside heats evenly. Okay? Let's look right here. The differences in air temperature. So, what's this a picture of here?
Sparky!
Sparky? It is sparky, isn't it? Okay, so the process of convection works because warm air and cool air behave differently. Think back to your fire safety rules. That's what Sparky's in there, right? If there is smoke in a room, where do you go? Where?
Outside.
How about if you can't get outside? Hello.
Did you
They
go
called Aaliyah back down to Miss Owens' room.
Okay.
So if you're in if there's smoke in a room, where do you go?
On the floor.
You go as low as you can on the floor. That's right. You go as low as you can, and that's just kind of a rule when you're around fire, right? If you can't get out, right? If you can't safely get out, you go right on the floor because what happens to the warm air? And so if it's smoke that's coming from warm air, right?
Yeah.
So the warm air does what?
Right.
Rises. What's the cool air do?
Cool. Go
It
down.
goes down.
It sinks, right? So the oxygen's gonna be cooler, it's gonna go down. Okay, so you got the idea. So warm air rises, cool air sinks. So as air temperature changes, so does its density and its behavior. This same phenomena happens with all gases and liquids. So not only does it happen with air, but it happens with other liquids, even ocean water, okay? And also happens in the semi-solid mantle of Earth. So the warm air rises, cool air sinks. Okay, so that's why you drop. If you can't get out, you drop and crawl, right? To see if you can get out in a fire. Okay, so let's look here at convection in the Earth's mantle. So look at those arrows right there. Look at the arrows. What are the arrows doing? So if you
They're
look right here,
circulating.
there's the mantle, and the air is doing this right here. It's just going, it's circling, right? Circling. Hot. As it warms up, it rises, and then when it gets up here, it cools off because it's away. It's not so high a temperature, right? And then the temperature starts to fall. And what does it do? It sinks again, right? So it's kind of a cycle. It's a cycle. So because the outer core of the Earth is so hot, here's the outer core, the material that it's close to that point will warm up. It's kind of like being in an oven or something, right? As it warms up, it becomes less dense, causing it to rise closer to the surface. And then when it gets closer to the surface, what's it do? It cools off, and then it what?
Goes down.
Sinks back down again, goes back toward the outer core heats it up, and then what does it do? It starts rising. And it's a cycle, right? How are they doing it there that way? Okay, got the idea? Okay, so convection in the Earth's mantle. As the substance gets closer to the surface of Earth, they cool down because they become more dense. And then what happens as it gets dense? It sinks, right? Dense air sinks. Okay, notice that the substance within the Earth have a circular motion, not a straight up and down. So it doesn't do this. It goes like this. Actually, it goes like this. Or it goes like this. Up, down, circular motion, right? Not a straight up and down, it's just a circular motion. Kind of like I think of a rolling boil is what I do. I think of a rolling boil. Okay, look right here. Oh my. Okay, look right here. This is a model of what's going on. The process will continue to repeat itself endlessly inside the Earth, and it does. And it's been doing that for guess how long? 4.5 billion years. That's what scientists say the Earth is about 4.5 billion years old. Psst. Jonathan, mask on the nose there. There'll be consequences if you can't follow that rule here.
I know.
Just want you to know. Okay. Okay, so let's answer a question here now. You ready to answer this question? This is number 7, and it's on slide 40. Everybody on slide 40?
Yes.
Yes.
Okay, so look right here. So which one of the following statements best explain why plates move? You remember we said the Earth is filled with these plates that float, right? There's 18 plates, I think. Some people say less, some people say more. Okay, so which of the following statements best explains why plates move? Is it heat from the sun provides energy for them to move? Or is it that heat in the mantle causes plates to slide? Mark your answer, A or D. Everybody got an answer?
No.
What? It's either heat from the sun provides the energy for them to move. The plates are underneath the ground, by the way. They're underneath the crust. So is the sun going to get to them? Or is it heat in the mantle causes the plates to slide? Think of I like chocolate pudding. So I'm thinking of these plates on this chocolate pudding. As that chocolate pudding heats up, what's it going to do? No, all right? Okay, so A or D, mark your answer. Everybody got an answer?
Yes.
No.
I'm moving on. A or D, that's your answer. Okay, which statement is correct? Which statement is correct? Hot substances rise. Cold substances rise. Does your Coke rise? When you put ice in it, does it rise? Does it start floating in the air? How about your tea? Does it start floating in the air when you put hot tea in a cup? Does it start floating in the air?
Yeah.
Okay. How about materials with low density sink? How about materials with high density float? What? So which one of those statements is correct? Okay, are we ready to move on here? 42. We'll talk about that question here. Just go ahead and give an answer. Who say no? Who says no? They didn't get an answer. Who is that not getting answers? You not getting answers, or you getting answers? Okay. Look at number 9. Materials in Earth's mantle move in a circular direction. Materials in Earth's mantles move in a circular direction. You look at those. Remember those graphics we looked at of the air around the mantle, between the mantle and the outer core? Were they moving up and down, or were they moving in a circular direction? Mark. So this says that they were moving in a circular direction. Is that a true statement or a false statement? Everybody got an answer?
Wait, that's the end of the lesson. Because there's another lesson after that.
Are you serious? That means we can grade them, doesn't it? Woohoo! Okay, so we're going to stop the lesson here.
Yay.
We're going to stop the lesson, but Mr. Hughes is going to grade these. Okay. Okay, and so for you at home, you're going to answer these questions here. Stop the video, look at your student copy, and answer those questions. Okay.